Okay, so again, we can go back to using just this part of our Ladybug component. You can see we covered more or less the dry bulb temperature. If you want to eventually start migrating into more of human outdoor comfort, you can start to use things such as the dew point temperature or the wet bulb temperature that it was previously referred to, and relative humidity. Again, Chris Mackey has some great video tutorials on integrating those as well. Then you can see those next two parts are wind speed and wind direction. These are, again, what we need to do our windrow diagrams. So I'll go again back to my visualization, scroll down to Ladybug windrows. And like I said before, when you look at these components, you know that the descriptions that have the underscore just on the left-hand side are what are required. So I need hourly wind direction and hourly wind speed. That's simply these two. I don't know why they have them crisscrossed. So you have to drag wind speed down to there and then wind direction up there. I figured they'd hopefully get that resolved by now because it could be confusing. And the one other thing that's different about this is that you may remember the sun path immediately created your visualization of that. In this case, you have to also use a Boolean toggle to activate it. So when you plug in this, you'll see that it's gray. It means it's working, but in Rhino, you don't see anything showing up. But if you move down here and see this one that says run it, again, it has that underscore on the left-hand side, suggesting that it's required. So I'll grab my Boolean toggle, drag it into there, and hit true. I don't know why you have to do it for this one and not the other one, or vice versa, but that's just the way it is. And here you go. Here is your windrows. It's giving you all the times throughout the year in which different wind speeds and directions occur. For the most part, our wind speed and direction comes from the west and south and in between. For those of you that have lived here long enough, you've probably noticed and observed that it does for the most part. That's where a lot of the storms come from, so makes sense. So again, this is the inventory part of the exercise. We need to understand that analysis of portion. So instead of looking at it purely for the sake of speed and direction, we can also compare it with the corresponding temperatures of that time. So understanding that wind can be either hot or cold, we need to treat each condition differently. So when it's warmer temperatures out with winds, we generally want to find ways to cool that. So we can use things such as trees that have high evapotranspiration rates to help cool that. We can use other passive structures like cooling towers to do that as well. And then vice versa, when we have those really cold winds coming through, creating some kind of windbreak to generate that wind shadow for our site. I did a little digging into that as well, and I saw all sorts of different mixed information on the wind shadow. I saw, like Danny had said, that the height of either a wall or a tree, whatever that height is, that it projects the wind 3 times that distance. So if it's 10 feet tall, it doesn't hit the surface until about 30 feet. But then I also saw ones that said it was 20 to 25 times its height. That seems a bit extreme. So I would suggest you research that on your own, and regardless of what you find, reference that material so we can look at it further. So I don't want you guys to just default to say, well, Danny said it's 3 times, so that's just what I'm going to do. You'll hear a lot of numbers thrown out. And Danny says those things, I say those things, but that's often based off of our own research and knowledge of the subject. It's most likely new to you, so it's expected that when you start to apply these more quantifiable metrics or variables, that you also find or reference that research material. That's just a good habit to form and obviously prevents plagiarism. So like I said, we want to look at the wind for both when it's hot as well as when it's cold. So what's nice, again, you can see that there's annual hourly data. So that's asking for any additional component that we want to introduce. So in this case, again, I'm going to just use the dry bulb temperature. And this will take a second too. And you can see nothing really changed, but if I move over to the right, we not only have just the wind speed and direction, but now we have temperature related to that. So we can see again that those hotter temperatures are coming from this direction, as well as a little less in that direction. The cooler temperatures definitely come mostly from the west and southwest. So what's nice is, again, this is giving us an entire overview of those temperature readings. It'd be best to isolate that in a variety of manners. We can do something just like we did before with the temperature readings, where we can say, okay, let's just see where the wind's coming from when the temperature is above 100 degrees or below maybe 65 or 70 degrees. So let's do that. Again, it's asking for that conditional statement. This one's a little bit different. Instead of doing A is greater than or A is less than a certain temperature, you can see if you read this description that it's saying it's always going to consider, I believe it's wind speed as their A variable. So you'll have to use a B variable instead. So in order to look at temperatures above 100 degrees, I'm going to do the quotations as B greater than 38. And I'll drag that into there. And you'll see a slight change. I don't know why it changes scale, but it does. So now you'll see that now, for the most part, the hotter times of the year, the majority of that air is coming from the south and a little bit also on the southwest. So this could essentially refer to those hotter times of the year. Not necessarily just the summertime, but anytime the temperature exceeds 100 degrees. And again, it also gives you the standard wind speed and direction on this row. So it's always going to produce two, one showing speed and direction, and then this one with those corresponding temperatures. So the light blue and darker blues refer to that 100-degree mark versus the red and oranges being about 44.4 degrees Celsius. Again, I have no idea what that is, but I am curious. Well, let's use this factor to test just that. So 44.4, oops. So you can see 111 degrees. So this is a good way to, again, look at your warmer winds. So you know that they're going to be coming from the south and southwest. This, again, we're using Illustrator, we can explain that a little bit more effectively. And then vice versa. So again, like I suggested in the lecture notes, we have different seasonal patterns. So there's the warmer temperatures as well as those cooler temperatures that need to be addressed differently. So now let's do B is less than, I believe it's 18 would be a good degree Celsius. I think that's around 65 or 70 degrees. Don't quote me on that. So again, you see now the difference for that. So for the most part, those cooler winds are coming in from the west and west-southwest, and then those temperatures related. So for the majority, the wind speed for those temperatures, like those stronger winds are definitely warmer. And then those really cool temperatures, so the negatives, are not as frequent, but still needed to address. So like I said, I mean, this is definitely a little less demanding through the Ladybug components to do, but it's still going to be just as effective. Unfortunately, like the sun path, it doesn't produce any outputs to figure out like what the precise date or time in which that occurs, like the sun path, so we can't know exactly, which is unfortunate, but it's just something you're going to have to deal with for now, at least, until they come up with another update, which they do fairly frequently. The other part to do is if we are going to take the approach of using trees or vegetation to either cool the air or block it, we can use the tree characteristics to do that. So if we want to cool the wind or that temperature through the evapotranspiration from a tree, we can go online and search which trees are most effective at doing that, and then determining whether, again, they're deciduous or evergreen. And if they're deciduous, making sure that we pick one that's going to have its leaves during those hot temperatures. So instead of basing it by the temperature, we could also do it by that analysis period. So this would be a good time to, or a good way to put in actual dates to determine that tree foliage. So you could go to Analyze Visualization or Weather, choose the Ladybug analysis period, and set the dates for whenever that tree foliage occurs. Again, this is going to require you guys to do a little research and digging around to figure out which trees are going to be most ideal and when those have those tree foliage. And then when you find that out, you can plug in those dates into here. And so, again, like I said, this is going to be much more brief than the solar aspect. But the last thing that we haven't really covered is that, sure, you have these interesting graphs and diagrams that are being produced in Grasshopper. Again, it's nothing that we can actually use in Rhino. There's nothing that exists. We do have to make sure to bake it. What's nice is that for the most part, you can bake these directly into Rhino. The thing to know is that there's the different parts of this. So when you go to organize this in Illustrator, you want to make sure that you do these onto separate layers. Else, when you bake these and bring them into Illustrator, they're all going to read the same. as curves. So I'm going to go ahead and just stop that here.